Welcome to part 2 of case study ex4, where we'll continue to show how to apply key operators defined in RxJava reactive types. In particular, part 2 of this case study will explore how to combine Java streams and the various methods and aggregate operations it defines together with RxJava single operators in order to create, reduce, multiply, and display BigFraction objects asynchronously. Of course, as usual, you can find the source code we'll be covering here in this lesson in the link at the bottom of the slide. Once again, we find ourselves in my IntelliJ project, this time to look at the second part of case study ex4. Here's the ex4 class, which is the manager entry point. If you recall part 1 of this video, we took a look at the test fraction multiplications blocking subscriber method to see how it worked. And now we're going to turn our attention to test fraction multiplication stream to see how it works. As always, we register these two methods with the async task barrier, and then we use its run task method to have the operations running asynchronously in the background, while the main thread calls blocking get, which will then have it wait until all the asynchronous computations have finished in the background. So here we're going to take a look at test fraction multiplications streams. As usual, we create ourselves a string buffer to store the results we want to display at the end, and we immediately append the string printing sorted results because we're going to sort the results before we print them. And now we go into our stream. Now, what's interesting here is unlike before where we've used observables or singles to create the processing and guide the processing, this time we're going to use Java streams, which is a functional programming framework. And in particular, we're going to use the stream generate factor method. And you can see what it's going to do here is it will call the make BigFraction factor method, which we've looked at many times before, but just quickly for completeness, creates a large random big integer as the numerator, a much smaller big integer as the denominator, and then makes a big fraction out of these two. And you can see that it does not do any reductions because it passes false in as the second parameter. So this will basically generate random big fractions until the cows come home. However, we're going to limit the number of big fractions by using the limit aggregate operator. This aggregate operator is very much like the take suppressing operator defined in RxJava's observable class. And it says, stop the stream after we generate this many big fractions, where that is number 10. So we'll generate 10 of them. We then call the Java stream map aggregate operator. And what that's going to do is it does something akin to the RxJava concurrency idiom, except this time we're going to be mixing Java stream capabilities with RxJava capabilities. So here we're going to call reduce and multiply fraction, which takes in the unreduced big fractions one at a time, and the scheduler's computation. So all of a sudden, we're switching between Java stream functions, and now we're using RxJava functions. And in particular, you can see here, we're going to call reduce and multiply fraction, and we're going to have it do the computation using singles and return a single. So we use single from callable to perform the reduction on the unreduced fraction parameter. We subscribe this onto the scheduler that's passed in, which in this case is going to be the computation scheduler. And we're going to go ahead and apply flatMap method in order to do a multiplication of the reduced fraction we got from callable with our S big reduced fraction, which, as you probably recall, is this large big fraction that has a large numerator and a large denominator. And that will also take place in the background. So what gets returned from this particular method is a single. So we're going to have a bunch of singles that are coming back from map. So this is kind of interesting. So notice how map is being called here. This is Java streams map. And we're basically ending up with a stream of singles to big fractions. So we're really mixing two different metaphors here, two different frameworks. We're mixing Java streams and RxJava types. How we're going to reconcile that is we're going to use the Java streams collect method, except we're going to pass in a collector that we create using this toSingle factor method. And the toSingle factor method belongs to a class which is called singles collector. And you can see that the toSingle factor method makes a new singles collector. Well, what is a singles collector? A singles collector is essentially a collector implemented with Java streams framework capabilities. And it implements the collector interface, which comes straight out of Java streams. And it's parameterized with 3 types. The type that will be used as the type that's the type of the stream is going to be a single, because we're going to have a stream of singles. We're going to be accumulating those things into a list of singles, and we're going to return a result, which will be a single to a list of items of type T. In this particular case, of course, these are going to be big fractions as the type, but we made the singles collector be generic, so it could be reused in other contexts. So let's take a quick look at the methods that go into a collector. So we have something called a supplier, which is a function that creates and returns a new mutable result container that will hold all the singles that are in the stream. In this case, we make that be a constructor reference to an array list. So the mutable result container will be an array list. We then have something called an accumulator. And as you can see, what the accumulator does is it returns a by consumer, which in this case will just be adding to a collection. So it'll just be the add method reference that's defined for collection. So we can add things to our list, which is our mutable result container. We then define a combiner, and a combiner actually isn't used because we're not doing parallel streams. We're doing sequential streams here. But were we to do parallel streams, then the combiner would be used to take two lists of singles to type T and then basically append one to the end of the other. And then finally, where everything gets interesting is the finisher method. And this method does the final transformation from the intermediate accumulator type, which was an array list or a list, into the final result value. And you can see that the final result value is going to be a single to a list of type T, or big fractions in our case. So let's see how this works. This is actually going to use a very cool Java, RxJava single operator called zipArray. And at a high level, what we're going to do is we're going to take the list of singles that we've been accumulating into by calls to the accumulator, and we're going to call zipArray, and we're going to convert the list of singles into an array of singles. That's just needed by zipArray. And we're going to pass in a combiner. And so what this is saying is, after all the singles finish being reduced and multiplied, then call the combiner. And you can see the combiner up here is a function that takes a dynamically allocated array of objects, which of course in our case are really big fractions, and it returns a list. And so what we do is we use Java streams and their of method to convert this array. This BF array is just the big fraction array that's passed to us as this parameter here. We convert that into a stream of objects. Then we use the map method. This is a Java streams map method, mind you, to convert the object into an object of type T, which in our case is big fraction. And then we finally use the collect method as part of the Java streams collector framework to collect this into a list. So we end up with a list of objects, in this case, big fractions. And what comes back from zipArray will be a single that wraps around that list of items of type T, or in our case, big fractions. So very, very cool example of how to combine Java streams and its collector framework with the concepts of singles from RxJava. There's another method here called characteristics, which we just say we don't care what the ordering is because it doesn't really matter for our purposes. So that is essentially going to be what our singles collector does. And then if you come back over here, you can see that we collect this into a single list of big fractions. And then from there, we're going to use the single from completable operator. And we're going to take that list, and then we're going to sort and print it. And this is essentially the same sort and print method we saw earlier in a previous example, where we do a parallel quicksort and a parallel heap sort of the list using from callable and subscribe on that are defined in single. So both those things go in parallel. And then we use the single ambArray operator to pick whichever one finishes first. And whichever one finishes first, we go ahead and display the results that are now sorted by using this consumer local variable called display list, which, as you can see, just takes the list and goes to each element and appends it to the string buffer. And then when we're all done, we display the string buffer by converting it to a string, and we return ignoreElement. And that comes back over here as the return value from flatMapComplete, which comes back over here as the return value from test fraction multiplications stream. So that shows how it all works. Let's now go ahead and run the program again real quick. So if you recall, when we ran this earlier, when we were doing part one of the video, we showed the results for test fraction multiplications blocking subscriber. As you can see here, just because of the randomness of our random number generator, we ended up with some very large big fractions this time. And then down here, this is the output from test fraction multiplications stream, which, as you can see, sort the results and also have some very interesting big fractions. So this example really demonstrated how easy it is to combine Java streams and the Java streams framework with RxJava. Now, would you actually do this in practice? Probably not. But I just wanted to show that it was possible and demonstrate how you can interwork between these various functional and reactive streams frameworks that are now part of the Java ecosystem.